Greeting everyone. My name is Avi Loeb. I'm a professor of science at Harvard University. And I was asked at a forum recently, how do I define an intelligent civilization? And the way I define it is a civilization that follows the guiding principles of science, namely cooperation and sharing of evidence-based knowledge. And it is pretty clear right now that our problems are global, and there is no better vehicle to cooperate than science, because science is based on sharing knowledge that was gained by evidence. The biggest risks that humanity is facing at the moment is that we are wasting a lot of resources on fighting each other and trying to feel superior relative to each other. And that starts with nations competing with each other, engaging in conflicts. And if you just think about it, we could use all these resources for much better purposes. The best example is that in 1939, Winston Churchill wrote an essay talking about how exciting it would be if we were to search for other intelligent civilizations elsewhere in the universe. And he didn't have a chance to publish this essay because he was drafted to become the prime minister in the UK to fight the Nazi regime. And we all know that the Second World War had a huge toll on humanity. The US alone had to spend $4 trillion. And 75 million people worldwide were killed in the Second World War, about 3% of the world population. And 2/3 of the Jewish population in Europe was annihilated. And just think about that. And this is just one illustration how humanity is not necessarily acting intelligently, following the guiding principles of science, cooperating and sharing evidence-based knowledge would provide us with a much better future. And I believe that science and technology carry the promise for a much better world for all of us globally in the distant future. And of course, that involves also going out of Earth, because currently all our eggs are in one basket here on Earth. And if a catastrophe happens, everything that we care about will go away. So going to space is extremely important, and that's one of the frontiers that humanity is facing. To us is Proxima Centauri. It's about 4 light years away. So it takes light 4 years to get there. And if we were to use chemical rockets to travel there, it would take us about 50,000 years, roughly the time that elapsed since the first humans left Africa. So if we wanted to get there today, we would need to leave when the first humans left Africa. And that's a long time to wait. You need many generations to be born on the spacecraft, and it's not at all clear that the voyage will be safe and stable. So the reason is that humans and in general biological creatures were not selected by natural evolution, Darwinian selection, to travel between stars. We were selected to live for up to 100 years or so on a planet like the Earth. And so we are not really suited for very extensive space travel. And there are lots of risks. Aside from the duration that is very long, there are cosmic rays that could damage our bodies within a year or so of exposure. Many of the cells in the human brain could be damaged, and that could be a health risk, a major health risk. For even living on a planet like Mars that doesn't have a magnetic field protecting it from cosmic rays, or an atmosphere that would protect humans. So if we ever establish a colony on Mars, we will have to dig deep down and live in a cave, or perhaps build infrastructure that protects the humans over there from cosmic rays. That's non-trivial, and traveling through interstellar space is even more hazardous. So in my view, it makes much more sense to send equipment. And that's why also, if we ever meet signatures of advanced civilizations, we are likely to meet equipment. And the equipment may not be more boring than living creatures, because it could be artificial intelligence. We now know that some of the systems that we built are already able to think better than humans in some aspects. And within a decade, we will have artificial intelligence systems that learn from their own experience and decide based on their own thinking what to do. And if we can do it within a decade, probably other civilizations could have done it long ago, because most of the stars formed billions of years before the sun. And if they had the technological civilization, it could have had much more time than we had over the past century to develop artificial intelligence systems. So you can imagine a spacecraft that is equipped with artificial intelligence as well as with a 3D printer, so that it can replicate itself just like a biological creature on the surface of a planet. And such systems can go from one planet to another if we know how to make life synthetically. At some point, we are working on it in laboratories, and some people are getting close to creating synthetic life. And if we ever manage to do that, you can imagine a situation where artificial intelligence can keep record of the DNA information of the animals it wants to produce, and then with the aid of 3D printers, it could potentially use the raw materials on a planet to make life, and life of different forms, rather than carrying it from Earth. And I see that as a much more practical approach to reproducing life as we know it on another planet, rather than carrying it all the way from Earth to that planet.
Very interesting approach. And can you tell us why you started studying astrophysics, and what attracts you to space?
I came to astrophysics by chance. I was mostly interested in philosophy at a young age. I grew up on a farm in Israel, and used to collect eggs every afternoon. And on weekends, I drove a tractor to the hills of the village and used to read philosophy books, because philosophy addresses the most fundamental questions we have. It doesn't provide answers, but that was fascinating to me at a young age as a teenager. And then circumstances led me to work in physics. And I felt that it was an arranged marriage kind of after a while. But once I got tenured at Harvard, I realized that maybe I'm actually married to my true love, because I can address questions that used to be philosophical using the scientific method. And that's a great privilege as a scientist. And that's what I'm doing now. And the universe is really remarkable. I mean, we are born into this world like actors put on a stage without knowing what the play is about. And we tend to think the play is about us. I mean, I can understand that, because when my daughters were young and they were at home, they thought the world centers on them and that they are the smartest. But when we took them on the first day to the kindergarten, they got a psychological shock to realize there are kids that might be smarter than they are. So perhaps, first, we should be modest and not assume that the play is about us. And indeed, the stage is huge. And moreover, the play has been going on for 13.8 billion years since the Big Bang. And we just came at the end. So obviously, the play is not about us. But perhaps what we should do is look for other actors that has been around for longer and ask them, maybe they have a better idea about what the play is about. And that's one of my main research activities, trying to find evidence for other civilizations.
Yes, thank you very much. And Professor, could you tell us, so we know that we're not alone in the universe. Could you please tell us maybe some facts, direct or indirect, confirming the existence of intelligent beings in the universe that are besides us?
In fact, I have a new textbook that is about to be published at the end of June, that will be more than 1,000 pages long, to be published by Harvard University Press, Life in the Cosmos. And in it, I discuss all the important clues that we have about the possibility of life on many other planets. And the one thing we realized recently is, based on data from the Kepler satellite, that not only we are not at the center of the universe, as I mentioned before, but moreover, what we find in our backyard is not special, it's not privileged, because about half of the sun-like stars have a planet the size of the Earth, roughly at the same separation. So if you arrange for similar circumstances as we find here on Earth, you might as well get similar outcomes. And most of the stars formed billions of years before the sun. So they could have had technological civilizations that predated us. And 1 billion years is a lot of time to send probes throughout the Milky Way galaxy into the habitable zone of other stars, and perhaps we were visited. I mean, that's quite a real possibility. In fact, in 2017, the first object that came from outside the solar system was spotted near Earth. It was given the name Oumuamua, which means in the Hawaiian language, a scout. And the reason it was given that name is because the telescope that discovered it was in Hawaii. And this object at first was thought to be another rock coming from a distant star. But then as we studied it more closely, it didn't look like a comet or an asteroid that we have seen before. There was no cometary tail of gas or dust around it. It had a very extreme shape, most likely flat, and it was pushed away from the sun by an additional force that could not have been related to evaporation of gas, because we haven't seen that gas around it. So most likely it was pushed by reflecting sunlight, and therefore it had to be very thin, like a sail. And then in the future, we should search for similar strange objects that do not look like a comet, do not look like an asteroid, a piece of rock. And then if we notice them sufficiently in advance of their approach to us, we can send a spacecraft equipped with a camera that will take a close-up photograph. And we've done that with the asteroid Bennu using the mission OSIRIS-REx. We even landed on Bennu and scooped up some material from it. It was clear that it's a rock. And this material will be brought back to Earth in 2023. So in principle, if you imagine a mission like that to an artificial object that looks weird at first, just like Oumuamua was, we could potentially land on it and read off the label "Made on Planet X," and perhaps even bring the technology back to Earth. And it would be as exciting as putting your hands on a cell phone that is not yet available to the public and has a lot of new features and nobody else knows about it. It would be really a lot of fun to figure out this technology.
Interesting. But why is it important to learn about extraterrestrial civilizations and study these phenomena and, get onto these rocks and understand all these things, that we are not alone? How will this impact our lives?
It is extremely important for us to figure out if we are the smartest kid on the block, because it would give us a better perspective about our place in the universe. It will shape our aspirations for space. We could also learn from more advanced civilizations, because they could have had more time to develop their science and technology. So it could give us a leap into our future rather than wait until we figure out the same technologies and the same science. We could learn from them directly. It could potentially feel like cheating in an exam, where you look over the shoulder of a student next to you in trying to find out the answers. But since there is no teacher grading us, it would be a great benefit for us to just leap 1 million years into the future and learn something that will take us a long time to learn on our own. And then, of course, there would be some impact on our religious beliefs, our philosophical beliefs, and many other aspects of our life. And that includes also international relations, because we might realize that cooperation is a much more valuable resource for us rather than fighting each other. And because there is another species out there, and we are all part of the human species, and we should work together in order to communicate or relate to other species out there.
Thank you. And Professor Loeb, could there be another planet behind the sun? And how can we confirm or deny the presence of the planet behind the sun?
Well, we are moving around the sun. So as we move around the sun, we could potentially look in all directions throughout the universe. And within the solar system, there is no planet out to a distance of maybe 100 times the Earth-Sun separation that could be hiding from us. But beyond that distance, there was actually a claim that perhaps there is another planet that we have not discovered yet. It's called Planet 9, and people suggested that it may exist at about 500 times the Earth-Sun separation because they saw some potentially indirect effect of such a planet on other objects, other bodies moving. And we haven't yet found such a planet, but we may very well have planets that we have not yet detected in the outskirts of the solar system. The solar system goes out not to a few hundred times the Earth-Sun separation, but actually to 100,000 times the Earth-Sun separation. At that distance, you have the so-called Oort cloud, which includes bricks that were left over from the construction project of the solar system, of the planets in the solar system. The planets were made out of smaller building blocks, each of which was much smaller than us, and some of them were thrown out during the construction of the planets, and they were kicked to a much bigger volume, which is called the Oort cloud, that goes roughly halfway to the nearest star. So if you think about it, every star could potentially have an Oort cloud of leftover bricks or rocks from the formation process of its planets, and those are touching each other. These Oort clouds are touching just like billiard balls that are densely packed.
Awesome. Thank you. And we also we've come across information that our solar system was either artificially created or was somehow changed, and that other systems are arranged so that the large planets are located closer to the star, and as they move away from the star, the size of the planets decreases. And in our system, like the large planets, they seem to be in the middle. Have you heard something about that?
Well, we do see a lot of architectures of the planetary systems out there, and the solar system has some unique properties, but one way to understand the properties is to say there were many more planets or objects in the solar system. Some of them were on orbits that were unstable, that after a while were kicked out of the solar system. And indeed, when people do calculations, they find that there could have been more bodies, but they were kicked out by the force of gravity, due to perturbations by, for example, Jupiter moving around the sun. We have no direct evidence for anything beyond that that shaped the solar system. And when we look at other planetary systems, we do find planets as large as Jupiter, some of which are much closer than Jupiter is to the star. And we do find the Earth, down to Earth-sized planets as well. And it seems like there is a big diversity in the architecture of planetary systems, and perhaps some of the special features of the solar system were just by chance. There is no evidence that any engineering project was involved.
Thank you very much. And you've been in this field for a very long time. And could you please tell us what difficulties have you encountered in your professional activity and in science in general? And how can these problems be resolved, in your opinion?
Well, I was asked by the Harvard Gazette, the official magazine of Harvard, what is the one thing I would like to change about the world? And my answer was, I would like my colleagues to behave more like kids, because kids explore the world, try to understand everything around them, and they do it by putting skin in the game. They are willing to get bruised, and we do see them getting bruised. And they don't have necessarily a prejudice about subjects, and they just explore the world innocently. And I really connect to that approach. And the problem is that when these kids get to academia or become adults more generally, they forget their childhood curiosity and try to behave in a way that will protect their image. And they do not take risks, they do not innovate, and they do not approach problems by putting skin in the game, by getting some sense of the risk involved in exploring new territories. And that's very unfortunate because it slows down our progress. When a kid looks at an object, the kid would turn it around and play with it. And we think that the play is for fun, but in fact, the play is for the kid to figure out what the object is like. And an adult would look at the object from one direction and just say, I pretty much know what's on the other side, and I would rather not waste energy and time on exploring it. So it might work in many cases, but it also avoids discovering things that you haven't expected. And in science in particular, we often discover things because it's a learning experience. So sometimes nature is more imaginative than we are. And if we don't allow ourselves to play, to put some skin in the game by making predictions that will turn out to be wrong, if we don't allow our image to sometimes not be optimized because we have a preconception of what things might behave like, and then we do the experiment and they behave differently. So the point is, it's not about us, it's not about our ego, it's more about a learning experience, it's a dialogue with nature that we are supposed to have as scientists, and experiments should educate us. And they did. If you look at 100 years ago, quantum mechanics, which is one of the fundamental pillars of our understanding of reality, all the electronic devices we use are based on quantum mechanics. It had a huge economic impact on humanity. So quantum mechanics was completely unexpected. And Albert Einstein resisted some of the fundamental aspect of quantum mechanics, which he called the spooky action.
Spooky action at a distance.
Yeah, and now we relate to it as entanglement. And he said that he doesn't believe that can be possible, and then experiments proved it wrong. And so obviously, when you work at the frontiers, you might have resistance to something that nature shows you in terms of interpreting it, but it doesn't really matter if you are wrong, because that's part of the learning experience. And so my point is that we should allow ourselves to make mistakes if we want to innovate, if we want to discover new things. And unfortunately, a lot of people care a lot about how many likes they get on Twitter, and they look around rather than looking at the ball. They look at the audience in terms of playing basketball. And that's unfortunate. And I think that discovery will be accelerated if people would pay more attention to the ball than to the audience. And that is my main message to my colleagues in academia, but also to anyone, even in the business sector, that is trying to innovate.
Thank you, Professor. It's very insightful, and it's great that you also mentioned that we should keep being curious and not just protecting the titles or our egos. And Actually, cooperation is also the basis of interaction in nature, even if sometimes we see that things like seem to be violent, but we have never seen like any lions killing more gazelles than they need to resell, to some other guys in the jungle. So this is so very true, and we wish that scientists hear you and start to cooperate and keep being interested in uncovering the real nature of things with the purpose of helping humanity.
If you look at the history of humans, the worst trait that you find is people trying to feel superior relative to each other. And that brings us to very dark places, including racism, including nations that try to kill others. And this is the worst in human nature. And it also appears in other incarnations of people trying to feel that they are part of the elite and that they are superior relative to each other. And fundamentally, people trying to protect their image by not thinking outside the box and not discovering things that they didn't know and just believing that what they already know must be the future. And if you go back in time, you find the example of the philosophers during the days of Galileo that refused to look through his telescope because they knew that the sun moves around the earth. If you look at the sky, you see the sun moving. Obviously, the sun moves around the earth. We are at the center of the universe. And they didn't bother to even check if there is evidence to the contrary. And what did it accomplish? Basically, they maintained their ignorance and the earth continued to move around the sun.
Professor, and I have this question for you. In your opinion, what is the number one most important task right now in space exploration and in science?
I think we should figure out if we are alone, if we are the smartest kid on the block. I think that's the most exciting question. And I think the public has its heart in the right place on this. Unfortunately, answering this question is not being funded at a suitable level. It's being pushed to the fringe, to the outskirts of the mainstream of science. And that's not the appropriate place for it. I do think that it belongs to the mainstream, that we do have the instruments. It's just a matter of us investing the funds in the search for technological signatures of other civilizations. And we are searching, for example, for the nature of dark matter. Most of the matter in the universe is made of particles whose nature we don't know. And we have been searching for 4 decades. We haven't found yet the particle that makes most of the matter in the universe. There is 5 times more mass in those particles than there is in ordinary matter that we are made of. So that's an example where we are searching in the dark, and it has been part of the mainstream. So psychologically, people were happy to invest a lot of money in the search for dark matter. But at the same time, the search for technological relics of other civilizations was almost completely unfunded. 1,000 times less funded than the search for dark matter. And even though society cares a lot about it. So I think that needs to be corrected. And it's definitely an extremely important question. And I call it space archaeology, finding objects that perhaps are floating in space that may indicate to us that the existence of advanced civilizations that we can explore.
Thank you very much. And you also mentioned artificial intelligence. We're also going to talk about this topic. And in the sense that artificial intelligence is great because it could replace so many humans. It is better at things. It doesn't get tired, even if we talk about robots that do surgeries, that write codes, such as IT codes. But also the crisis that we see with this is that it's going to replace humans in the work field. What is your take on that?
My take is that the artificial intelligence is only for our benefit, in the sense that we can focus on more important questions rather than being the hunters and the gatherers that have to worry about getting food to the table or working on mundane issues. We can perhaps think about going to space, think about how to make humanity survive all the challenges that are facing us. And instead of providing services, we can let machines do that. And of course, machines can also help us explore space, because imagine that we discover a piece of equipment, some probes that were sent by other civilizations that are very advanced, more advanced than we are. Perhaps we need to use artificial intelligence systems to interpret what we are seeing, the signals that we're getting from that equipment. The experience will be similar to asking your kids to tell you what the meaning is of some content you find on the internet, just because your kids are much more at ease with computers than you are. So we could use artificial intelligence that we develop to help us figure out artificial intelligence of other civilizations. And that's extremely important. That's a very important tool. I should also say that artificial intelligence offers a lot of opportunities for people that used to work in the humanities to get engaged in the sciences, because there are many ethical questions that are brought up to the forefront. For example, if an artificial intelligence system decides whether a person should be treated medically one way or another, and the person dies, who do you hold responsible, and what are the criteria by which a system would operate such that it brings the most good to all humans? There are deep philosophical questions that need to be addressed if we give more authority to artificial intelligence systems. There are, of course, issues to do with discrimination, that if machines learn based on past experience and there was some bias involved in the selection of past searches, let's say for particular roles, if there was a preference for a certain type of people, then the system, when it learns it, will replicate that bias unless you correct it. And so there are many interesting questions. There are questions of privacy, and the humanities, people that work on philosophy, psychology, can get engaged and contribute to making better systems in the future.
But and I agree, those are all positive things, and that is what we should have in place. But right now, since we live in this consumerist society, in your opinion, what will happen to the people that will lose their jobs due to the fact that artificial intelligence will take over and will do a better job?
Yeah, I think the economy should change in the sense that already right now in wealthy countries, people work 5 days a week. So you can imagine a work week being even shorter, but people will get paid. I mean, because the same kind of work can be accomplished in part by the help of machines. And altogether, it will relieve people from the need to work on services. And you can define new challenges that people will be engaged in that are not related to services. You just need to redefine the goals of society and pay people perhaps even for the days that they don't work in the way that they work right now. So I see it as a positive change in the sense that it will free people to focus on more exciting, more interesting problems. And of course, the economics should be such that they would have everything they need. And having the machines do some of the work would allow the rest of us, the humans, to enjoy our lives better. If we organize society properly, if we compensate people beyond the tasks that are currently being performed by humans.
Or we could just, organize our society in such a way that since the machines are already doing everything for us, we could just enjoy our lives, and do the things that matter to human beings without working just to survive. This is also a possibility.
Exactly. I mean, we are along that path already. If you think about the challenges that used to be for the early humans in the jungles, they had a lot of concerns about surviving in the environment they live in. And nowadays we face much fewer challenges and we live a better life. But we can live an even better life if we had machines doing a lot of the work for us.
Yes, better and more accurately, right? I mean, machine will not lose miss a vein or,
Right.
yes, it'll be
But of
great.
course, there are some issues that will come up, and that has to do with the interface between humans and machines. Because if machines have authority to decide about the fate of humans, you have to implement the appropriate ethical conditions for how the machine makes decisions. But there is also the risk of machines taking over in some way. You want to prevent an unstable society. You want to make sure the humans are in charge.
Yes, yes, absolutely. And also, Professor, I just have this quick question. What are your thoughts on free energy? I know you said if we use the energy we have today to travel to other planets, it's going to take us a numerous amount of years that, that we will not see in a few lifetimes. What are your thoughts about the need of free energy to be discovered and used?
So, in principle, there are several concepts that allow travel at a higher speed than chemical rockets, and also that do not require that you carry the fuel with you. So, in principle, you're using energy that is available for free. So, for one example, is a light sail, where you're being pushed by light, and that could be the light from the sun, that we get for free. And then on a system like that, you can perhaps get energy from the interaction of the system with the ambient medium as it travels through it. You can charge batteries when you pass close to stars. There is a lot of energy in space that one can, in principle, tap if you have a sufficiently advanced technology that you're using. And I assume that if there are other technological civilizations, they already thought about it and solved these issues. And so we can only try to replicate them. Obviously, you can also have a fusion reactor in your spacecraft that takes a relatively small amount of fuel to create a huge amount of energy. I mean, the sun is basically a fusion reactor, but you can create that possibly artificially. I mean, we are working on it. We haven't yet accomplished that task. So maybe we will in a few decades, and then we can have space propulsion by fusion. But otherwise, one can think of ways to tap the energy available in space rather than carry the fuel with you.
Thank you. Thank you very much. And Professor, how important is it today to build a society, a creative society, where humans' life is of the highest value instead of the consumerist society that we live in today?
Yeah, I think it's extremely important to pay attention to humans rather than the economics of making a profit, because after all, we are all living our life, and it's the purpose is to make everyone as happy as possible, and that implies that it's not so much about getting products or hardware. It's more about making people feel fulfilled in their life. We live just for a short time, and we better feel happy rather than accumulate goods around us. And so not as much attention is given to that. And perhaps if we have machines like artificial intelligence taking the roles of the difficult tasks, and I should say it's also robots, so that humans can free themselves for the things they really enjoy doing. And I very much look forward to that, but it depends on how we design the future society. If we make it oriented around the human happiness and providing people with meaning to their lives that will make them happy, that's much more important than providing them with the goods that they will pay for.
Yes, thank you very much. Right now, people from over 180 countries around the world are working on a major international project called Creative Society. And the purpose of this project is to formulate a model of society where human life is of the highest value and implement it internationally. Could you please tell us, for you personally, what are the key criteria for the Creative Society? And also, how important do you think it is for people to take an active part in the process of transforming the society?
Academia should not be considered as an occupation of the elite. In fact, everyone can be engaged in the scientific process. And I think it's important for scientists to explain what they're doing. It's important for people that develop technologies to attend to the needs of people that use those technologies. And altogether, it's society and scientists and technologists working together towards solving the problems that matter to society. It makes no sense for people in academia to work on problems like how many angels can sit on the tip of a pin, because even though it can demonstrate that they might be smart or sophisticated, it does not promote our knowledge on issues that matter to most people. I think it's extremely important for everyone to be engaged because people approached problems from different perspectives, and as a result, if there is a puzzle or a difficult problem that needs to be resolved, having people with multiple perspectives, multiple views as a result of their different backgrounds helps identify the correct solution. If all the people that address a challenge are approaching it from the same perspective, they may miss something really fundamental. So this is the practical reason why I think diversity is extremely important, because it involves diversity of opinions, diversity of perspectives. And that means that we should allow everyone to participate and encourage everyone to participate. Different ethnic origin, different genders, different backgrounds, are all welcome to take part in the challenges that face humanity in the future. And since the invention of the internet, knowledge can be shared among many more people than before. And I think we are heading in the direction where there will be opportunities for everyone to take part.
Yeah,
thank you very much.
Definitely a great idea. Yeah, thank you.
Yes, thank you so much, Professor. It was a wonderful interview, and thank you so much for being with us today.
Well, thanks for inviting me. I had a great time.
Civilization. Can we consider our society to be civilized? The world has come to a verge. The situation is serious. The only way out is evolutionary quantum leap. Leap from doom of consumer society into a whole new format. Creative society. What are the three conditions to become a civilization?
First one is unification. The second one is the absence of a tyrant, meaning a tsar, a king, no matter what we call him. And the third mandatory condition is possession of free energy. That's when a civilization begins to develop.
Human life is the highest value. Life without wars. Ecology restoration. Benefits for a human in various fields of existence. Instantaneous solution of all material problems. Possession of free energy. Physics of the future. Manipulation with microparticles and management of micro-world. Manipulating matter. Wasteless production. Instant healing of human body. Prolongation of human life beyond the usual lifespan. Non-invasive cosmetic corrections of human body. Almost immediate acquiring of skills on professional levels. Highly developed technologies. Flights to other galaxies. colonization of new planets, super civilization. And what if all this is just a beginning?
The creative society is our only chance.